In today's lecture, we will investigate where infrared radiation comes from and where it is used both in our everyday lives as well as in scientific research. We will also explore whether infrared radiation is a danger to our health. Infrared radiation falls in the range of electromagnetic spectrum between microwaves and the red end of visible light. It is usually further subdivided into three broad ranges. Firstly, we have far infrared radiation, which has wavelengths from 50 to 1,000 micrometers or microns. Next is mid-infrared radiation, with wavelengths from 2.5 up to 50 microns. And then we have near-infrared radiation, with wavelengths ranging from 0.75 to 2.5 microns. As the name suggests, this radiation is right on the edge of the visible spectrum, just below red. That's why we call it infrared. To give you some idea of those sizes, a human blood cell is about 7 microns in diameter, while a human hair ranges in width from about 17 microns to anywhere up to 180 microns, of course, depending on its type and color. So, as you can see, the sizes of infrared's wavelengths are still not on the range where we can detect them with our eyes. Nonetheless, it can sometimes be felt as a sensation of heat. Naturally, the greatest sources of infrared we are exposed to comes from the sun. Almost half of the sun's energy that reaches the earth is infrared radiation. And you can feel it physically as warmth on your skin. The rest is mostly visible light and a small amount of ultraviolet. It was British astronomer William Herschel who first discovered infrared radiation in the year 1800. Herschel was interested in measuring the temperatures of the different colors of visible light. To do this, he used a prism to split the light up into its different colors. He then placed thermometers directly in the path of each color. During his experiment, Herschel found that the temperature systematically increased from the blue end to the red end of the spectrum. He then went one step further. Herschel placed the thermometer at a spot beyond the red light, where there was no light visible. He found that the temperature was even higher. This led to the discovery of infrared light. So, as you can tell, infrared radiation is closely related to heat. In fact, every hot object emits infrared radiation. By hot, we mean anything that has a temperature above absolute zero. That's 0 degrees Kelvin, or minus 270 degrees Celsius. And the intensity of this infrared radiation is directly proportional to the temperature of the object that it is coming from. Humans are strong emitters of infrared radiation, as you can see from this image from an infrared security camera. So yes, you and I give off radiation. It is a radiation higher in frequency than what our mobile phones emit, but of a lower intensity. This is because we are emitting thermal radiation in the infrared part of the spectrum. Moving charged particles in our body have heat, or thermal energy. This heat energy is converted into electromagnetic waves, and in this case, it's infrared. These electromagnetic waves travel through the body to the skin and dissipate out into the surroundings. That's why, in a room full of people, it gets very hot, because there is so much infrared thermal radiation being generated. But be aware, although the terms infrared and thermal radiation are often used interchangeably, this is not quite correct. In fact, thermal radiation refers to all electromagnetic radiation at different frequencies emitted by any object due to its temperature. If we were hot enough, we would radiate visible light. But that's just incompatible with life as we know it. We would have to be over 500 degrees Celsius. Thermal radiation at temperatures supported by humans is always in the infrared. There are many useful applications of infrared radiation. A TV remote works by sending out near infrared signals to change the channel or the volume on the TV. Night vision cameras work by detecting infrared light and converting it into a visual image. Earth scientists use infrared detecting instruments on board satellites to measure thermal radiation from our planet and study natural heat sources such as lava flows and bushfires. Astronomers measure infrared light originating from different objects and physical processes in the universe in order to study the formation of galaxies, stars, and planets. Infrared light can penetrate gas and dust to reveal far more that can be seen in the visible light emanating from these objects. Conservationists are now using drones with infrared cameras to monitor endangered species at night when they are most at risk from poachers. Infrared radiation has also many medical applications. In particular, infrared thermography is a non-invasive imaging technique used to map the surface temperatures of the skin and trace various physiological functions. It has been used to help diagnose a wide range of illnesses, including fever, inflammation, dental problems, eye disease, and even breast cancer. For example, because tumours have increased blood flow and metabolic rates, they show up as a high temperature spot in thermograms. As well as being used for diagnostic imaging purposes, infrared radiation has potential for therapeutic applications. For example, it has been used to relieve pain and inflammation and improve healing of wounds. Infrared could also even be an effective treatment for some forms of cancer. So, infrared radiation has many benefits. But is it harmful at all? As with radio waves, infrared radiation itself is not generally dangerous to humans, as it is not ionizing and therefore not cancer-causing. It does not have enough energy or wavelengths small enough in size to remove electrons from atoms in our body. However, there is still a danger to be aware of. Sources of infrared radiation are used for generating heat in a wide range of devices, from heat lamps that keep food warm to tools for welding or glass blowing. These sources can cause serious thermal burns to your skin if you aren't wearing the correct safety gear. And if you are using these devices without eye protection, you can suffer damage from flash burns to the retina or cornea due to the tissue heating up. It is important to understand that these are effects of the heat that is produced by the infrared radiation, not from the electromagnetic radiation itself. So let's recap on what we have learned in today's lecture. Infrared radiation is produced by any source of heat, with the intensity of the radiation being proportional to the temperature of that object. Infrared radiation has a number of benefits and uses. Although it is not ionizing and therefore not cancer-causing, infrared could still be dangerous to us because of the heat associated with it and its sources.